Dear students, I welcome you all to the session on hydrographs and their analysis. Now, let me tell you what a hydrograph is. It seems from the word hydrograph, it is hydro plus graph. So, it is related to graphical analysis of some water. Am I right? Yes, it is more or less same, but the question arises in our mind is which water? We have many forms of water like groundwater, surface water and water in the form of a precipitation, and the precipitation in the form of rainfall, snowfall, drizzle, dew, mist and hailstorm, etc. In hydrograph analysis, we study about the surface water. In India, the rainfall is the main source of water. As far as India is concerned, our main concern is to analyze precipitation in the form of rainfall only, because snowfall is limited and it is specific to very few regions. So, we can say hydrograph means analysis of rainfall by considering several components of it. And our main concern is to estimate or predict how much water is going to accumulate at the gauging station in a stream at the outlet of the catchment due to the storm. So, to plot a hydrograph, first we need to know the knowledge of components of rainfall. Now, coming to components of rainfall, we have three components. The first one is initial loss, the second one is infiltration and deep percolation, and the last one is runoff. Coming to initial loss, it is the portion of a rainfall gets evaporated back to the atmosphere before reaching the surface, that is called initial loss. And infiltration and percolation is some portion of a rainfall joins the groundwater table and contribute to the groundwater storage. If it is a shallow groundwater water storage, we call it as a infiltration, otherwise we say it as a deep percolation. And coming to runoff, runoff is a draining flowing off of a rainfall from a catchment area through surface channels is called runoff. Then if we classify runoff, again there are three types. Those are overland flow, interflow and base flow. Overland flow is the rainfall directly gets converted as the surface flow and contribute to channel flow. Interflow or through flow is a part of rainfall initially seeps into the ground and reappears as a surface flow at other location. With a relative delay with respect to overland flow, it joins the stream flow. Then coming to base flow, it is a part of rainfall directly joins to the groundwater table and the groundwater table intersects with the surface water level of the channel. So, groundwater contributes to stream flow. This contribution of groundwater to a stream discharge is called base flow. This runoff is also called as a delayed flow. After understanding the rainfall and runoff relationship, we come back to our current topic, hydrographs. And what is a hydrograph? Means hydrograph is a plot of the discharge due to runoff in a stream plotted against time in a chronological order. It gives us the information about rainfall runoff characteristics of a catchment. It shows the response of a given catchment to a rainfall input, and also it consists of a flow in all three phases of runoff, that is overland flow, interflow and base flow. The typical hydrograph is characterized by a rising limb and a crest element and a recession curve. In addition to these components, we represent two inflation points to show the starting and ending of the peak flow, and two inflation points to show the starting and ending of the direct runoff. The inflation point on the falling limb is often assumed to be the point where direct runoff ends. Now, let us discuss about the factors which affect hydrographs. We have mainly two factors, physiographic and climatic factors. Under physiographic factors, we have basin characteristics, infiltration characteristics and channel characteristics. The storm characteristics, initial loss and evapotranspiration comes under climatic factors. Both physiographic and climatic factors influence the rising limb of the hydrograph, whereas the falling limb is affected mostly by physiographic factors. The reason behind is accumulation of water takes place in the rising limb and depletion takes place in the falling limb. Now, coming to the types of hydrographs, we have two types. Based on application of and a unit of time involved, hydrographs are classified as long term hydrographs and short term hydrographs. Under long term hydrographs, again we have annual hydrographs, monthly hydrographs and seasonal hydrographs. We have flood hydrographs and short term hydrographs, and these are event based. We further classify the hydrographs based on analysis of hydrographs. We have storm hydrographs, direct runoff hydrograph and unit hydrographs. Coming to storm hydrographs, while plotting this, we take total discharge including base flow versus time. In case of direct runoff hydrograph, we consider discharge excluding the base flow. About unit hydrograph, it is derived from the storm hydrograph resulting from a unit depth of rainfall excess or effective rainfall, we say, occurring uniformly over a catchment area and at a uniform rate for a specified period. We specify always a unit hydrograph along with time duration. So, we say d hour unit hydrograph. Here d means 2 hour, 4 hour or 6 hours like this. Generally, we derive unit hydrographs from a known isolated storm of specified duration. Once we know the appropriate unit hydrograph, we can predict the direct runoff hydrograph or a storm hydrograph. Now, we discuss about the steps involved in derivation of unit hydrograph. The first step is selection of storm hydrographs. While selection of storm hydrographs to derive a unit hydrograph, we should select isolated storms in such a way that the duration and amount of rainfall should be same for the selected storms, and they should cover entire catchment with 1 centimeter to 4 centimeters of effective rainfall. Now, the next step is how to obtain ordinates of mean d hour unit hydrograph out of selected storm hydrographs. Now, select number of isolated storms of duration approximately 0.9 to 1.1 times of d hour duration in the given catchment. So, we separate the base flow for each storm by adopting any standard method to separate the base flow. Then we calculate the area under direct runoff hydrograph, then we divide it by catchment area to get the effective rainfall. Once we know the effective rainfall, divide the ordinates of direct runoff hydrograph with respective effective rainfalls to get the ordinates of unit hydrograph of d hour duration. Then finally, we derive number of unit hydrographs of a given duration and obtain mean unit hydrograph out of all storm hydrographs we consider for the analysis. Coming to analysis of unit hydrographs, we have basically two methods, method of superposition and S-curve method. Let us discuss the method of superposition. We assume unit hydrograph is time independent and having linear relationship between the input and output in the method of superposition. Time invariance means we can apply unit hydrograph theory to predict the direct runoff hydrograph at any time. If we talk about linear response, it means unit hydrograph and direct runoff hydrographs are in linear relationship. For example, input of x1 of t is producing output of y1 of t and input of x2 of t is producing output of y2 of t. Then x1 of t plus x2 of t equal to y1 of t plus y2 of t. Then coming to the details of method of superposition, we derive ordinates of n d hour unit hydrograph from d hour unit hydrograph. So, we can adopt the method of superposition if n is an integer, not a rational number. For example, if you have a 4 hour unit hydrograph, we can derive unit hydrographs having a duration of multiples of 4 hours with this method. So, we cannot derive 2 hour unit hydrograph from a 4 hour unit hydrograph in the method of superposition. From 4 hour unit hydrograph, we can derive 8 hour, 12 hour and 16 hour unit hydrographs. It means we can derive multiples of d hour duration hydrographs only from the method of superposition. For example, I have ordinates of 4 hour unit hydrograph and I need to derive 12 hour unit hydrograph from it. Then the first step is to plot the ordinates of a given unit hydrograph versus time interval. Draw 2 more unit hydrographs lagged by 4 hours each in the same plot. By summation of ordinates of these 3 unit hydrographs with respect to time, we get direct runoff hydrograph of 12 hour duration with 3 centimeters effective rainfall. If we divide the ordinates of this direct runoff hydrograph by 3 centimeters, we get the ordinates of 12 hour unit hydrograph. So, we came to know how to get the ordinates of d hour unit hydrograph from the given storm hydrograph. Now, I will explain about S-curve method to get n d hour unit hydrographs where n may have a rational value or an integer value. Basically, we adopt S-curve method to overcome the problem of rational values of n. If we look into the definition of S curve, it is a hydrograph produced by a continuous effective rainfall at a constant rate for an infinite period. Theoretically, it is a curve obtained by adding infinite series of d hour unit hydrographs lagged by d hours apart, but actually we add few d hour unit hydrographs only, because at the end of a base period of the d hour unit hydrograph, S curve attains a constant discharge. We say S curve attained equilibrium discharge at the end of the base period of the first unit hydrograph. So, we add number of unit hydrographs lagged by d hour duration till the end of base period of initial unit hydrograph to obtain the S curve ordinates. To construct S curve, from the basic property of S curve, we have the ordinate of S curve at any time t equal to ordinate of unit hydrograph at the time t for time is less than or equal to d. If time is greater than d, then the ordinate of S curve at the time t equal to summation of the ordinates of unit hydrograph at the time t plus S curve addition for the time difference between time t and duration d. Now, we know how to develop n d hour unit hydrographs by method of superposition and S curve methods. If n is an integer, we may go for any method, and if n is a rational number, we derive unit hydrograph by S curve method only. By this time, we know what is a unit hydrograph and how to derive its ordinates in different methods. Now, coming to application of hydrographs, we can use this unit hydrograph theory to obtain catchment area characteristics, stream characterization and classification, estimation of surface water potential, reservoir studies, drought based studies and flood forecasting and flood damage mitigation. Finally, if I summarize the topics which we discussed in this session, we came to know how to compute direct runoff hydrograph from storm hydrograph by separating base flow. We have learned how to compute d hour unit hydrograph from the given direct runoff hydrograph, and we have also learned to compute the n d hour unit hydrograph from the d hour unit hydrograph by method of superposition and S curve method. Finally, we have discussed the importance of unit hydrograph theory and its applications. Thank you.